So good day everyone. So today we're going to discuss about solver problems involving electric charges, dipoles, forces, fields, and flux in a context such as, but not limited to, system of point charges, electrical breakdown of air, charge pendulums, and electrostatic inkjet printer. So first, what is electric charges and force? So electric charges are the basic source of electrical phenomena. They can be positive or negative, and they exert forces on one another. Like charges repel and opposite charges attract. So as you can see in the picture, if the charges have both the same signs, which is both positive and both negative, so they push away from each other, and that's what we call repulsion. And if the charges have an opposite signs, which is one positive and one negative, they pull toward each other, and that's we called attraction. So these examples show how electrostatic appears in everyday life. When you rub a balloon on your hair, electrons move from your hair to the balloon. The balloon becomes negatively charged, your hair becomes positively charged. Because of its opposite charges attract, the balloon stick to your hair. So next is Coulomb's law. So I know you're already familiar with that formula, which is F is equal to K times Q sub 1, Q sub 2 over R squared. So next is dipole. So a dipole consists of two equal and opposite charges separated by a distance. It is important because even if a net charge is zero, dipole can still interact with electric field. That's because the positive charge and negative charge are located in different positions. So when an external electric field applied, it pulls in the positive and negative charges in opposite direction, causing the dipole to rotate or align with the electric field. So the behavior of electric dipole in fields is first, in a uniform electric field, the dipole experiences no net force but a torque that aligns it with electric field direction. And if in a non-uniform electric field, the dipole experiences both torque and net force, causing it to move toward the stronger part of the field. These are the following most common formula of a dipole. So when calculating torque on a dipole in a uniform electric field, so potential energy of a dipole in an electric field, and lastly, the dipole moment.
So we have a real life example. So a charged comb in a water stream. After combing her hair, Maya's plastic comb becomes charged. When she brings it near a thin stream of water, the stream bends toward the comb. The comb holds with charges of 5 times 10 raised to negative 8 columns, separated by the distance of 0.05 meters. So find the its dipole moment. So the formula we use is P is equal to Q times D, which is P is the dipole moment, Q is the magnitude of the one charge, and D is the distance between the charge.
So next is electric flux. So electric flux measure how much electric field passes through a given surface. Flux depend on the field strength, surface area, and angle between the field and the surface. So the formula of electric flux is equal to E times A times the cos theta. So I don't explain it further because it's already discussed in our class.
So we have an example. A solar panel in a power station is exposed to a strong electric field created by the charged particles in the atmosphere during a maintenance operation. The electric field acting perpendicularly to the surface of the panel has a magnitude of 2 times 10 raised to 5 Newton per coulomb, and the area is 0.0002 meters square. So using the formula of electric flux, we need to only substitute it and we can get the answer.
So the following are the application of electrostatics. The first system of point charges, electrical breakdown of air, charge pendulum, and electrostatic inkjet printer. So first is the system of point charges. So when two or more charged particles are placed near each other, we experience the force of attraction or repulsion depending on the type of charges they carry. This interaction is called a system of point charge. So each charge affects the other through an electric force, and the strength of this force can be calculated using Coulomb's law, which shows how charge and distance influence the force between the particle.
So this is an example of system of point charges. So let's take a look at the figure and answer the following question. So the question are given there and also the answer, because all the answer of that question is given in the figure, like what are the charges of the particles, what are the magnitude, and so on. So these are the answer of that question.
So next is the electrical breakdown of air. So the picture explains the lightning happens because the charged clouds cause the air to break down and allow electricity to pass through it. This process is called electrical breakdown of air, and it can occur with the clouds, between clouds, or between the clouds and the ground. So there are different types of lightning discharges shown in the diagram. So first, intra-cloud lightning. So it happens inside one cloud between the negative base and the positive top. Next is inter-cloud lightning. So it happens between two clouds that have opposite charges. And third, cloud to ground lightning. So it happens between the clouds and the ground. Usually, when the negative charges in the cloud connect with the positive charges on the ground, that's the most common lightning we see. And lastly, cloud air discharge. So it happens between the clouds and the air around it when the air becomes ionized.
So, but first, what is electrical breakdown of air? So, electrical breakdown of air happens when an air can no longer block electricity because the electric field becomes too strong. So, when this happens, air becomes a conductor and allow electricity to pass through. So, it occurs when charge buildup exceeds the dielectric strength of material. So, this means the electric charge becomes stronger than what can air handle. Once the electric field goes beyond the limit or the electric strength, the air breaks down and lets electricity flow. And next is electrons move in one direction and positive ions move the opposite direction. So this means that when air breaks down, atom lost electron. Electron move toward the positive side and the positive ions move the negative side. So your opposite movement creates an electric current in the air. Next is when an electron is removed from nucleus, it becomes positively charged. So if an atom loses an electron, it now has more proton than electrons. Because of this, the atom becomes positively charged, forming a positive ion. And lastly, in a very high electric field, air becomes ionized and changes from an insulator to a conductor. So, air normally does not allow electricity to pass or insulator. So, but in a very strong electric field, electrons are knocked off air molecules. This ionization allows air to conduct electricity, so it changes from an insulator to a conductor.
So the dielectric strength of air approximately 3 kilovolts per every millimeter. Its exact value varies with the shape and size of the electrodes and increases with pressure of the air. So when electric field becomes strong than this limit, the air can no longer act as an insulator, it breaks down and becomes a conductor. So once there is a lightning, it is safer to stay inside the car since it serves as electrical shield, making the electric field zero. So the metal body of the car acts as an electrical shield. So when lightning strikes, the electric charge stays on the outer surface of the car's metal. So and the electric field inside the car becomes zero. That's why people inside the car are safe. The lightning doesn't pass through them. So if if for example na lightning, kay if naka inside the truck, inside the car kay mas safe daw siya. Charge pendulum. So there are 5 stages in a charge pendulum. So first stage, an aluminum ball with zero net charge assume a vertical position at the end of a thread or a string. So as you can see in the image of the stage 1, an aluminum ball hangs straight down. This is because zero net charge. So in simple word, it is electrically neutral. Since nothing is affecting it, it stays in a vertical position at the end of a string. And next is the stage 2. So a negatively charged rod is brought across aluminum ball and the ball become polarized. So in the stage 2, the negatively charged rod is brought close to the aluminum ball. The ball does not touch yet, but something happens. The charges inside the ball start to separate, the negative charges move away from the rod, and the positive charge move towards it. This process is called polarization. The ball is still neutral overall, but the charge inside are rearranged. So as you can see in the image. And next is the stage 3. So the positive pole of the aluminum ball is attracted to the negatively charged rod up contact. So, dire na to makita ang attraction. So for the stage 3, imong makita sa image nga ang aluminum ball moves toward the rod. This happened because the opposite charge attract the positive side of the aluminum ball, which is now closer to the rod, is pulled toward the negative charge. That's why the swing until it makes contact. So in the stage 4, after contact, the ball becomes negatively charged by the charge transferred to the point of contact and is repelled by negatively charged rod. So this means the ball touches the rod. When it is happen, some of the negative charges from the rod transfer to the aluminum ball. Because of this charge transfer, the ball becomes negatively charged. Now that both the rod and the ball have the same negative charge, they repel each other. That's why you see the ball moving away after the rod. And lastly, the stage 5. So the aluminum ball will stop at equilibrium in a position deviated from vertical at an angle determined by the charges of the rod and aluminum ball. So in this final stage, as you can see in the image, the ball stop at the angle instead of going to the center. This happened because both rod and the ball are now negatively charged, so they repel each other strongly. The balls stay in the new tilted position because the repulsive from the rod balances with the force of the gravity pulling it down. This position is what we call equilibrium.
And next is inkjet printers.
That's the one, as you can see in the image, that's the one that inside the printer. So first question, how does the nozzle of the inkjet printer function? So the nozzle sprays tiny droplet of ink into a paper in a specific pattern. So inside the printer, the nozzle works like a very small hose that releases ink in a controlled way. It is uses electricity to signal to heat or push the ink, causing small droplet to come out very fast. These droplets land in the exact spot on the paper to form a letter or images. The nozzle moves back and forth quickly across the paper, allowing the printer to cover the whole page with precise and detail. So the second question is, how do inkjet printer produces colors and images on a paper? So inkjet printer use a tiny dots of colors ink, magenta, yellow, and black to mix and create different color and images. Printer combine these four basic colors in different amount and position. For example, mixing cyan and yellow creates green, while mixing magenta and yellow makes red. The printer spray this colored ink in a very small and blending the colors. The printer can produce realistic photos and colorful graphics. And last question, what concept in electrostatic are applied in inkjet printers? So the concept are electrical charges, electrical field, and electrical force. So why? So before the ink droplet leave the nozzle, they are given an electric charge. When these charged droplets pass through electric field, they are deflected or moved by electric forces toward the correct spot on the paper. So these help the printer place each droplet exactly where it needs to go. Without the electrostatic principle, the droplet would not be direct accurately, and the print quality would not be clear or sharp.